In this video, we're going to explore integrals involving exponentials and logarithmic functions, and we did kind of do some before when we were doing the U sub, but we're going to see them again. So here's our first two rules of exponential functions can be integrated. E to the x is e to the x all day long. When you integrate it, it's e to the x. When you do the derivative, it's e to the x. And then plus c if you're integrating, not plus c if you're doing derivatives. A, being the base a raised to the x dx, must have started out with a to the x divided by the natural log of a plus c. Now this one makes sense, right? Because when we did d dx of a to the x, this was a to the x, the natural log of a. So if you were undoing a to the x, clearly, kind of like when you're doing u substitution, you are missing the natural log of a. So you end up with, when you do a to the x, when you integrate it, it is a to the x divided by the natural log of a plus c, where a is a positive number bigger than 0. So let's go ahead and do these integrations. We're going to do a little u sub if you want. You don't really have to do u sub, but you could. We're going to let u equal to x. And this is only to remind me that when I do the derivative, I need to have a 2 dx, and I don't see that. So I have to have 1/2 e to the 2x plus c. Now, I didn't do a full u sub. I put that, started to do the u sub to remind me that I should have had a 2 here, and I don't see a 2 anywhere there. So I had to have started out with 1/2 e to the 2x plus c. Same thing here. I'm going to let u equal negative 3x. That means du must have been a negative 3 dx. So you can see I'm going to have to, when I integrate this is going to be negative 1/3 e to the 3x plus c. And I can always check these. I can always check what I think when I integrate it, what I think the antiderivative is by taking the derivative. And you can see when I take the derivative of this negative 1/3 and this derivative of negative 3x will cancel and become 1 e to the negative 3x, which is where we started out with. So that's really kind of nice. Now this one, if I started out with, again, I can do this with a u sub, and I would have said let u equal 2 to the x, du would have been 2 to the x, the natural log of 2 dx, and you can see I don't see that 2 to the 2, excuse me, whoa. You don't see the natural log of 2, so we know that when we integrate this is going to be 1 over the natural log of 2x plus c. Similarly, if I let u equal 3 to the negative x, du would have been 3 raised to the negative x, the natural log of 3 multiplied by the derivative of negative x, which is negative 1 dx. So when I integrate this, I need both a negative 1 over the natural log of 3 multiplied by 3 raised to the negative x plus c. Easy peasy lemon squeezy. When we are integrating our logs, now we talked about this a little bit before in our previous example, and I actually introduced the whole natural log stuff. This, remember when I have the integration of 1 over x dx, I can't reverse the power rule, because if I try to reverse the power rule, I would be dividing by 0, and that is just not going to happen, because then we end up in a black hole and we all die. So let's not do that. So instead, I know when I see 1 over x, or x raised to the negative 1, it becomes the natural log of the absolute value, don't forget the absolute value, plus c. And when I see the natural log of x, I'm integrating the natural log of x, it's going to be x, the natural log of x minus x plus c. And I have the log based a of x dx is x over the natural log of a, the natural log of x minus 1 plus c. Boom, boom, shakalaka. So this is the same thing as 1 over x. And this is going to be 2 multiplied by the natural log of the absolute value of x plus c. Do not forget to put the absolute values. And this one I'm going to do by a u sub. I'm going to say, hey, let u equal the natural log of x. That means du is equal to 1 over x dx. Now this becomes du, this becomes u. So then this is just the integration of u du, which integrates to u raised to the 2 divided by 2 plus c. But I'm not integrating u, I'm integrating natural log of x. So this becomes the natural log of x, the quantity squared, divided by 2 plus c. And you're like, why didn't you put on the absolute values there? Well, back here I said let u equal the natural log of x. So by default, we are assuming the x's that I get to use are going to be bigger than 0. This is not true here. We don't know anything about x, and this ensures that it's going to be larger than 0. This is already there, so I don't have to put on the absolute values. All right. Let's do another u sub. So I'm going to let u equal the thing inside the squared, so it's going to be the natural log of x. And du is going to be 1 over x dx. So this 1 over x and this dx is du. This becomes u squared. So this is integration of 1 over u squared du, which is u raised to the negative 2 du. So this one I do get to reverse the power rule, and so it is going to be negative u raised to the negative 1 plus c. Now again, I don't have to put the absolute values because I already had restricted domains when I said let u equal. And so I have the negative natural log of x raised to the negative 1 plus c. And if I wanted to, I can get all fancy and put 1 over the natural log of x plus c. Totally fine with negative natural log of x raised to the negative 1. All right, so I have the natural log of the natural log of the natural log of the natural log, and there's some natural logs in there. Seriously, there's a lot of natural logs. So I'm going to start out with let u equal the natural log of x. Du is going to equal the natural log, 1 over x dx. Just got so excited about those natural logs. 1 over x dx. This is u. This is u. And this is u. So I circled a whole bunch of stuff. So I have 1 over u, the natural log of u, du. So, all right. Still not where I want to be, so let's do this. Let's say let v equal the natural log of u. That means dv is going to be 1 over u du. Oh, well, look at that. This 1 over u du is dv. This becomes v. And so let me erase this to get it out of the way. So then this becomes the integration of 1 over v dv, which is the natural log of v plus c, but we weren't starting out with v. And so we're going to back sub, and so this is equal to the natural log of the absolute value of the natural log of u plus c. But wait a minute, we're not done. So we didn't start out with u, we started out with the natural log. So we have the natural log of the absolute value of the natural log of the absolute value of the natural log of x. Bam. Plus c, and there it is. In all of its glory. It's actually not bad. I kind of like it. How wrong is that? Okay, let's take a look at my next one. Oh, tangent. Tangent. I can write tangent as the sine of theta over the cosine of theta d theta. Then I can say let u equal the cosine of theta. That means du would equal negative sine theta d theta. That means negative du must be equal to the sine of theta d theta. Bam! This is equal to negative du. This is equal to u. So then this becomes the integration of negative 1 over u du, which becomes negative the natural log of the absolute value of u plus c, which is the negative natural log of the absolute value of cosine of theta plus c. That's kind of nice. We're going to let u equal the sine of x, and du is equal to the cosine of x dx. And the reason I chose u to be the sine because that was the exponent on e. This gets replaced with du. This gets replaced with u. And so our integration is e to the u du, which is equal to e to the u plus c all day long, which is equal to e to the sine x plus c. And that is that final answer. All right. Now, G, what I'm going to do is I'm going to use the algebra rule that says if I have a minus b over a, I can write this as a over a minus b over a. So I'm just going to rewrite this as the integration of the cosine of x over x cosine of x minus x sine x over x cosine of x dx. So then this becomes the integration of 1 over x minus the sine of x over the cosine of x dx. Integrating each piece, we know the first one is going to be the natural log of the absolute value of x minus. Now, we just did this right up here on e, except for it already has a negative. So this is going to become plus the natural log of the cosine of x, absolute value, plus c. So that's kind of nice. On h, they're giving us a hint. We're going to let u equal 1 over x. So if we let u equal 1 over x, then du is going to be negative 1 over x squared dx. And so I have negative du is going to be 1 over x squared dx. And from this point, I know that x is equal to 1 over u. And you're thinking, why is this helping me? Well, we know that 1 over x squared dx gets replaced with negative du. I want to have this all in terms of u. And if I don't do something with the x in terms of u, I would have the natural log of x multiplied by negative du. So I need everything in terms of u. So this x gets replaced with 1 over u. Now my integration now is the natural log of 1 over u multiplied by negative du. All right. 1 over u is the same thing as u raised to the negative 1. The natural log of u raised to the negative 1, using our laws of logs rules, says I can bring that exponent out front so that it becomes the natural log of negative natural log of u. All right, so then this becomes the negative natural log of u multiplied by the negative du, which is just the natural log, the integration of the natural log of u du. Now, we have a formula for the natural log of x. We're going to use u, though. This is going to be equal to u, the natural log of u, minus u plus c. Now, this is one of the formulas that was given to me before, one of my rules up above. But u is equal to 1 over x. So this becomes 1 over x, the natural log of the absolute value of 1 over x. Actually, I don't even need the absolute value there. But I'm going to put it there just anyways. And then minus 1 over x plus c. And that's my final answer. And that's it for this section. So don't forget, you sometimes have to use the laws of logs. And the one that I used was I have the natural log of m raised to some power of p. This is p as a multiplier, the natural log of m, or log base a. So I use natural log because we like to use natural log. But anyways, that's it for this video. Nice short video on the integration involving logarithmic functions and exponential functions.